So today we're going to work with the HC-SR04 on one side of this sensor. This is a ultrasonic sensor, and we end up with a transceiver and a receiver. Um, and what this does is sends out high frequency pulses out of one, and then it'll bounce back off of a solid object and be picked up by our receiver, just like echolocation or sonar or anything like that. Does the same thing with ultrasonic pulses. So this little chip, we're going to end up just building the simple circuit for this, going into our Arduino IDE, programming a little printout for our serial monitor, and eventually we'll build up on the circuit and do more. So first, we're going to end up we're going to actually need just a few lead wires, our breadboard, our sensor, and our basic Arduino. We're going to end up sticking this guy in one of the spots here, just like that, with our rails running this way. And we have on this, if you can see, we have a VCC, a trigger, an echo, and a ground. VCC is 5 volts. Trigger is our transceiver. Echo is our pickup, and ground is just ground for the circuit. So I'm going to end up sticking this into our breadboard. We're going to run some basic wires from ground here and voltage. So I'm going to say voltage side, and end up sticking that right into the 5 volts on the board. VCC 5 volts. We'll go ground to ground, right next to 5 volts on the power rail. So the two outer things of our rail or our sensor there, and then those plugged into our power rail with 5 volts and ground. Just disconnected there. All right. And then we're going to take 2 more leads, and we're going to end up connecting those to our pin 8 and pin 9. So trigger is going to be pin 9, which is our first one closest to VCC there. I'm going to do that in gray. I'm going to go pin 9. And then I'm going to do pin 8. Oops, sorry about the camera there. Into echo pin. All right. So that's all we need. Basic wiring. Pin 8 into echo. Pin 9 into trigger. And our power on each side. So let's go pop into Arduino IDE and create a little program for this so we can trigger this to send out some pulses, receive those pulses back, and measure a distance. All right, I just opened up a new sketch. I'm going to end up file saving as a project here, right? And I'm just going to call it the name of the sensor itself. Save that. So now I'll continuously save for me. And I'll do my basic upload here of some, what do we got? Nope, I always forget. It's that. And we'll go title, HRS-04, right? And then this is just pin out. Kind of wrote this over here in my notes. And essentially all we're going to be doing here is in HC-SR04 and printing on screen, right? And so we know that we plugged in the trigger pin and the echo pin into pin 8 and pin 9. And so we can start with that, and we can start with our integers, and we can start with we'll call it trig pin equals 9. Close that. Integer echo pin equals 8, and we'll close that. That's literally all the pinout we need. We can drop down into our setup. I'm just going to get rid of this comment because we don't need it. But this, like as we remember, this only runs once, and we can start our serials in here, and we can establish what our pinouts are. So to start with that, we're going to end up with the pin mode, like we normally do, and we're going to have trig pin, and that mode is going to be an output because we want to trigger pulses out, just like that. And then we can do another pin here. Remember that uppercase mode, just the M on mode there, and we can do the echo pin. And that's an input, so that's taking in data from that bounce back. And we can close that. And then the last thing we need to do is, because we're going to communicating with the computer back and forth, and we want to read that on the computer, right? We need to do that serial with the uppercase serial dot begin, and with a baud rate of 9,600, or yep, and that's that. So just to kind of put some comments to some of this, a trig pin is an output, and our echo is an input. And we just have our serial begin that starts the communication with the computer. And so that's all we need for the setup. And we can jump down into the main code, which is just we have to end up triggering on the pin to send out those pulses for 10 microseconds, and then turning it off. And what that's going to do is just start that ultrasonic burst. And so we have to first make sure it's turned off. And to do that, we have to digitally write to the trigger pin and say, hey, off, right? And so that's a digital write, trig pin, and low. Make sure it's uppercased, and we can close that. We can put a delay, and if we went delay, we would have just delay in milliseconds. We actually want to delay in microseconds, and this delay is like 2, and so it's not milliseconds, it's microseconds, just moving the decimal point, right? And we end up having to close that, and you have to call it the microseconds, just so you know. And then we can digitally write this on this trigger pin. That would be a high, uppercase, and then we're going to want to do that for 10 microseconds. And so we have that delay on microseconds, and we do that for 10 microseconds. And then after that, we want to digitally write off again, and we do trig pin, like we called it there, and we go low. And we close that. So that's just sending our initial signal out for the precise 10 microseconds to trigger the pulse and start the ultrasonic burst. That's what we first have to do. Then we have to come back in and measure how long the echo stays high in milliseconds. And that can give us a distance using a simple formula, a distance formula in time. So I'm just going to put some comments here that I have. First, we're going to send out for that starting of the ultrasonic burst, and then we're going to end up waiting and measuring for that echo to come back round trip travel for the speed of sound. Obviously, in different densities of air, you have different speeds of sound, right? But we're just keeping this really simple, and we're going to end up waiting for that and measuring the distance it takes to go back and forth, right? So I'm going to end up adding some little comments here. So you're going to see what I'm actually talking about. Control Z, I don't want to do that. I want to delete that. We're just turning it off. Make sure it's off for a small amount of time. And then it's going to go high and turn on right here. All right. And then, make sure that's there so that actually is commented out and doesn't read that. And then we're going to turn that on for a certain amount of time, 10 milliseconds. This is the ping for the sensor, right? And then back to low just to turn it off so we can listen for that ping, right? And so this is just turning off the sensor, turning on the sensor, turning off the sensor, and then we're listening for that ping back, right? So now we got to listen for that ping back. We got to literally do a little bit of calculation here, and that's it. So we're going to want to, so we want to time out our listen because it might just go really far out and really far in, like because we want to do about this for 30,000 microseconds. That's microseconds. I don't have the mu. But what that equates to is about 30, squiggly line here, about 30 milliseconds, which is roughly, I think, the distance of 5 meters, the speed of sound. Is that correct? I could be wrong with that. So we don't want it to, the biggest thing is we just don't want it to hang up forever if nothing's detected, right? And so how do we do that? How do we measure the distance for the echo? Well, we're going to first do unassigned long. This is just unassigned long string. That's all this is establishing. It's very much similar to an integer establishment or anything like that. But we're going to call that duration. It's just another thing. We could have just said unassigned long up here, like this, established, and then bring in duration like that, and this will work. But what this is just unassigned long string, a string. And so duration equals pulseIn. So this is a built-in function, and so it's going to pulseIn, and what we're going to establish here is the echo pin high, waiting for a duration, right? Waiting for it to time out. So this is the read in, and so we're going to go here, pulseIn, and echo. Call it echo pin. And we have a state. We're turning on high. And we want this for the 30,000 microseconds. And we can close that. The next thing we have to do is the conversion. So that's just reading in that, getting our distance of where that is, and there and back. And then we have to read that in on duration. The next thing here is 3, converting time into inches. Handy you rule of thumb. We have inches equals microseconds divided by 148. We can do the math later. This just accounts for the speed of sound out and back. And so that with that simple calculation, we'll end up doing a simple if statement. If duration equals, we're looking for it, if it is equals 0, right, do this said thing, right? So if this is true, do this, right? That's all we're saying here. And so if duration is out of range, if it equals 0, which will be if it's way too far out or way too close, it'll read as 0. we want it to say, hey, you're out of range. So we want it to print you're out of range. So it kind of gives us a reference of like, hey, either A, you're way too close or you're way too far away. And so that will say, hey, we'll kind of tab that in a little bit. We'll say serial dot print ln out of range. All right. And so if it's out of range, do this, right? And so we close that at the end of the statement right here. So it's just inside this box. Do this. So if duration equals 0, do this, whatever is inside these two little curly brackets here. So I'm going to back that up a little bit. So we have our two little curly brackets. We have a close for that curly bracket, and we have a close for that statement. After that, we want to, so if anything else, we're going to do an else statement here. If anything else, do the conversion. Do the conversion so we can get the speed of sound there and back and figure out where the inches are. And then print that on the screen. That's what we're going to write here. And so if anything else, if it's not out of range, if it's too far out, or if it's too close, say out of range. But anything else, run our little conversion. And so we could say float. Because we're going to have this as a floating number, which means it could be a decimal point. Floating numbers is any decimal point, non-whole number. Inches, let's call it inches, equals our duration, our time, right? That, and then we're going to divide that by there and back, that 148 for the conversion, right? And we're going to end up closing that. We can actually, 148.0, that'll give us a decimal point here. We can also go like this. This is another item. It's just like those integers. And we can establish this up here first. And we got to make sure that we get rid of this statement here like this and just say inches. Hey, inches, store duration divided by this in inches. That's all that's saying, just like we've done before. Otherwise, you could establish it in the else statement, right? And then we can go serial dot print. And do that like that. We're going to say here inches, comma, 1. So what that's saying is 1 decimal point. All right, so that's all that's saying is 1 decimal place. That's all that's doing. Hey, print inches, the number inches, which is right up here where it did this calculation, and print it to the first decimal point. That way we can get a kind of an accurate reading here. And then we can say serial print ln, new line, right? And we can go space, space. Actually, let's go quotation, space, space, inch. And then we can close that. That'll kind of put some spaces. I'll print an inch, give us a little space, and then say inches. Kind of give us our unit for that. And that's essentially all we need to do for the else. All right, we can close that else statement like so. Make sure that this is closed with this one, and this one is closed with this one, and we can be done. We can hop out of that else statement, and then we want to say a delay. And we want to do a normal delay in milliseconds, sorry. And let's say a delay of 100. This just gives us a little bit of readable time for our serial monitor. Oh, not 1,000, 100. And that's it. So it's just going to run this loop, turn it on, turn it off, pick up the echo, then do the calculation if it's in range. If it's out of range, just print out of range. We got to make sure that this has a closed bracket here, and we're good to go. So let's hop over and plug this in and upload. All right, so we have our circuit plugged into with our USB into our computer. I'm going to end up clicking our COM here and uploading. And I should be able to go up here and say File, Serial Monitor, open that up, bring that up here a little bit. And we're reading about 16 inches out. We have a item it's blocking or it's bouncing back off of. What this is doing again is sending a signal out from the transceiver, bouncing off of something. So let's move my hand in here. So signal is going out, boom, bouncing off, receiving back, right? And so I have my hand placed roughly about 3 to 4 inches out. It's going bounce, 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 bounce. So out and back, out and back. And that's what it's reading right now off of my hand. And so I can move this back and forth. You can kind of see that's about 6 inches there, 4 inches, 2 inches. And if I get too close, it's going to read out of range because it can't bounce. What it's trying to do is bounce and pick up, but it can't pick up because it's too close. And so if I get too close, it's just going to read out of range. And if it was too far, it's just going to read out of range. So there's that. But I want to show you here quick because I also showed it on the screen, that basic calculation on the screen. It's kind of hard to see, kind of hard to explain, but distance in centimeters equals speed times time, right? And since we have this going 2 directions, this distance is here to here, right? We're gonna have to divide that time by 2, right? And so if we have distance, our speed is the speed of sound, and our time is just the time that goes there to back, there, back, there, back, right? And so to get the distance, we take the speed of sound, which in this case we're using units of centimeters per microsecond. And so normally the speed of sound is 343 meters per second. But we use unit conversion. We bring it down to centimeters per second, or sorry, centimeters per microsecond, and that's 0.0343 times that by time divided by 2 because we want it in one direction, one way, not both the time, not time here and here. So we have to divide that by 2. So because we only want it one way, not both ways back, right? And so that equates out to roughly this, and that would be our distance in centimeters. And to convert from centimeters to inches, we have to divide by 2.54, and you end up with this. Inches equals that original equation right here that we're seeing, and then divided by that 2.54, and that equates out to roughly that. That's how we ended up with this equation here. I just wanted to show that quickly. Not that you'll need to know the math, but that's just where I got it. So, again, that's bouncing back and forth. That's why we have to divide by 2. So, there you go. There you have it.